In this video, we're going to talk about the empirical rule, distributions that are bell-shaped, okay, or symmetric. All right, so what does bell-shaped and symmetric look like? So I'm going to draw a horizontal axis here. So I'm going to do my best to draw a bell-shaped curve. It's not too bad. Okay, so right in the middle of my bell-shaped curve, I'm going to do an average. Okay, so I'm going to take an X bar. Okay. So the bell-shaped curve, the empirical rule says that if I go out one standard deviation each direction, so I go out a standard deviation this way. So if I move out a standard deviation this way, that's S in that direction. And to move out a standard deviation this way, that's minus S in that direction. This point right here would be X bar minus S, and this point would be X bar plus your standard deviation S. That's not a 5, that's an S, okay? So what this area represents is 68% approximately of the data, okay? So 68% of the data falls in this area right here, okay? Now, if I go out another standard deviation, so go out another S this way, and then, another S this way, right? Then what is that going to be? That's going to be X bar plus 2S, so 2 standard deviations out, and then X bar minus 2S, 2 standard deviations in that way. Then the amount of data encompassed in this area is approximately 95%. 95% is it within 2 standard deviations, okay? So 95% falls in those 2 standard deviations of the mean, okay? And then last, if I go out another S standard deviation and another S standard deviation, okay, what this says, so I go out X bar minus 3 standard deviations this way, and X bar plus 3 standard deviations this way, then what that's going to be encompassing is roughly 99.7% of the total data lies within 3 standard deviations of the mean. Yes, I did a shorthand for standard deviation with SD, okay? So we write standard deviation so many times. Anytime I write SD, that's going to mean standard deviation, okay? Just, so shorthand, SD, and standard deviation are the same thing. So in blue, 3 standard deviations will be all of this right here, okay? So all of that between here and here, everything in between, that's 99.7% of all of it, okay? So what does that mean? Well, that means that what's left out here and what's left out here on the far tails add up to 1 minus 0.997, which is 0.003, okay? Which is like 0.3%. So that's a really small amount of area that exceeds these two. So once you get out 3 standard deviations, you pretty much covered for all practical purposes, unless we're talking about, something with smaller chance than 1 out of 1,000, okay? Basically, this is like 3 out of 1,000. So that's still pretty small odds to get 3 out of 1,000. Now, the empirical rule only works if we're talking about something that's bell-shaped, symmetric, okay? So the distribution has to be in the bell-shaped curve, and it has to be symmetric, okay? In the next video with Chevyshev's theorem, we'll talk about what to do when you do not meet those conditions of bell-shaped.